Hey, welcome to the Explainer. You know how it goes. You have an app that's lightning fast, you love it, and then one day it just grinds to a halt. So today we're going to get to the bottom of that. We're talking database performance, we're talking scalability. Basically, we're going to figure out why things slow down and, more importantly, how you can stop it from happening. We're going from a single line of code all the way up to massive system architectures so you can see how to keep things running at top speed. I mean, we've all been there, right? You're using an app, it's part of your daily routine, and then nothing. Or it slows down so much it's basically unusable. It is so frustrating. But that lag, that little spinning wheel, it's often a sign that things are going well. It's a symptom of growth that the system just wasn't ready for. So let's unpack why that happens and what to do about it.
All right, I want you to think of this as a 4-level video game for system design. We're on a quest for pure speed. We're going to start small on level 1 by mastering a single query. Then we'll level up to table structures, then the whole system architecture, and finally, we'll face the boss level, keeping an eye on everything to make sure it all runs smoothly.
Okay, let's jump right in. Level 1. Every single thing you do in an app, every click, every search, it fires off a query to a database. If you get this part right, you are building on a rock-solid foundation for a fast system. But if you get it wrong, oh boy, you're setting yourself up for a world of hurt down the line. So let's talk about how to write queries that are actually built for speed.
Think of these as the 4 golden rules for query optimization. Rule number 1, filter early. Use your where clause to slash the size of your dataset right away. Seriously, the less data you have to sift through, the faster your query will be. Second rule, stop using select star. Be specific. Only ask the database for the columns you actually need. Third, keep it simple. If you have a massive monster query, break it down. Use things like CTEs to make it more manageable. And fourth, and this one is huge, use your indexes wisely. They're like cheat codes for finding data fast.
Now, what if you don't know what your query will be ahead of time? What if it needs to adapt on the fly? Well, that's where dynamic SQL comes in. It's like a Swiss Army knife for your database, letting you build and run queries at runtime. But, and this is a big but, with great power comes great responsibility. If you're not super careful about cleaning up your inputs, you could leave the door wide open for major security risks like SQL injection.
And what about navigating really complex nested data? Okay, imagine trying to draw out a huge company org chart. You'd start with the CEO, then find their direct reports, then their reports, and on and on. That is exactly what a recursive CTE does for your data. It's just a really clean, elegant way to walk through those kinds of hierarchies without writing a tangled mess of code.
Okay, so we've leveled up. We've mastered the art of the single query. But, a blazing fast query doesn't do you much good if the data it's looking for is a total disorganized mess. And that brings us to level 2. We're zooming out from the query itself to look at how the actual structure of your data tables can make or break your system's performance. Let's think about your data table like it's a giant encyclopedia. With horizontal partitioning, you're basically splitting it into different volumes based on the year. So if you only need data from 2023, you just grab that one book instead of lugging the whole set off the shelf. Now with vertical partitioning, you're doing something different. You're taking all the heavy glossy photo pages and moving them to a separate appendix at the back. That way, you can flip through the main text way faster. Both methods just make it quicker to find what you need. So indexing a huge table, it's like creating a detailed index for an entire library. You wouldn't list every single word in every book, would you? Of course not, that would be insane. You just index the really important stuff, the keywords, topics, authors. It's the exact same idea for your database. You've got to be strategic. Only index the columns you search on the most, and you will save a ton of time and resources.
This brings us to a classic dilemma: speed versus efficiency. Indexing is kind of like putting a supercharger on your car. It'll go a lot faster, for sure, but it also burns more fuel every time you hit the gas, or, in this case, every time you write new data. Denormalization, on the other hand, is like having a pre-calculated trip summary on your dashboard. Instead of recalculating your average speed every second, you just glance at the number. It's faster to read, but you're using up valuable dashboard space for information you have to keep updating.
All right, we've optimized our queries, we've structured our tables. Now it's time to put it all together. Welcome to level 3. Here, we're thinking bigger. We're designing a system that's not just fast for 100 users, but for 100 million users. We are talking about building an architecture that's truly built to scale, a system that's ready for pretty much anything you can throw at it.
So the first big question you have to ask is, what kind of race are we running here? A sprint or a marathon?
If your system is handling a huge volume of quick, simple transactions, think e-commerce checkouts. That's a sprint. You need an OLTP system, built for speed and data integrity. But if you're analyzing mountains of historical data to spot business trends, that's a marathon. For that, you need an OLAP system, built for heavy-duty, complex analysis. They are two totally different tools for two totally different jobs.
And that leads us to another key idea. Think of partitioning like organizing your closet. You put all your shirts in one section, all your pants in another. It's all still in the same closet, it's just much, much neater. Sharding, though, that's like your closet got so full you had to go out and buy a whole new dresser just for your socks. You're actually spreading your data across completely separate databases to handle a massive amount of traffic.
So, you did it. You built the perfect system. It's fast, it scales, it's a thing of beauty. You've beaten level 3. But wait, the game's not over yet. For our final level, level 4, we're going to talk about how to keep that system running like a well-oiled machine. This is all about monitoring, maintenance, and basically staying one step ahead of any problems.
For this level, you need to put on your detective hat. You are constantly on the lookout for clues, trying to solve the mystery of what could possibly slow your system down. That means you've got to analyze query execution plans to find bottlenecks, check wait statistics to see what your system is waiting around for, and use every tool you've got to crack the case before your users even know there's a problem.
Now, as a detective, you're going to run into some sneaky culprits. Imagine two people trying to pass each other in a narrow hallway. A deadlock is when they both just stop, each one stubbornly waiting for the other person to move first. They are completely and totally stuck. A live lock is way more subtle. That's when they both keep trying to get out of each other's way, but they keep mirroring each other's movements, stuck in this endless, polite dance, but making zero progress. Both are bad news, but one of them is a lot trickier to spot.
So what's the big takeaway from all of this? Well, it's that performance is a journey, not a destination. It's a never-ending cycle. You optimize your queries, you structure your data, you scale your architecture, and then you monitor everything all the time. Each level we talked about builds on the last one, creating a system that isn't just fast today, but is resilient and really built to last. And that really leaves us with one last crucial thought. Your system might be running perfectly right now, handling everything you throw at it without breaking a sweat. But what about tomorrow? What about next year? Technology doesn't stand still, and the demands on your system are only going to grow. So, the real question is, are you ready for what's next? Are you building a system that's just good enough for today, or are you building one that's ready for the future?